We are building a railroad to space. Let's take a journey into the future and explore how humanity will travel through the cosmos.
Kinetic launchers are operational. Spin launch throws small uncrewed spacecraft into low Earth orbit without the use of rocket fuel. Electric ion engines, creating thrust by electrically charging a gas, become more powerful and are used to power the Lunar Gateway space station. Humanity watches as larger and larger space structures are built. Rockets launch, deploying expandable and inflatable payloads. An entire space station is sent into space in a single launch. The International Space Station deorbits, burning up in Earth's atmosphere and crashing into the ocean. SpaceX begins launching the basic building blocks of their orbiting fuel station. The age of orbital refueling advances. The depot cryogenically stores fuel and will soon store mechanical spare parts for spacecraft, allowing space vehicles to be maintained and repaired in Earth's orbit, never needing to land. This starts dividing spacecraft into two types, those that are designed to launch and land on Earth, with added heat shields, fuel storage, air brakes, and parachutes, and those that are designed just for the vacuum of space. The building of SpaceX's fuel station also tests the working prototypes of the Starship Mark II, twice the diameter, with 4 times the amount of internal space than the first-generation Starship, large enough to be a space station itself. The Artemis moon base refuels a spacecraft. They are testing the first rocket fuel made on the moon. The first small-scaled nuclear fusion-powered spacecraft begins testing, producing energy without nuclear waste. Fuel is in the form of hydrogen isotopes. Hydrogen is present in the atmosphere of many planets and on asteroids. To create nuclear fusion, an environment like the center of the Sun is needed, with extremely high temperatures and pressure. It is the gravitational forces of the Sun that squeezes the hydrogen together in the center, creating nuclear fusion. On a spacecraft, the fuel is heated into a plasma, then squeezed, using either magnetic confinement in the form of large electromagnets or by inertial confinement, using lasers and pistons to push and compress the fuel. A few kilograms of fuel could power the average home on Earth for about 9 years. And for a spacecraft, fusion power will cut future travel times in half, while an advanced ultra-high energy fusion engine will propel a spacecraft to Mars and back in 45 to 75 days. 2035. This year will be known as the first Great Crossing. The journey to Mars is shortened by months, down to 80 days, because Earth and Mars are closer than normal. This is known as a perihelic opposition. A number of starships, a colonial fleet, and armada are waiting in parking orbit around Earth, ready to set off when the launch window opens, making Elon Musk the first space admiral. The Starshot Alpha Centauri program launches a swarm of 1,000 tiny spacecraft to collect data. Using solar sails, they are powered by lasers on Earth. Other solar sail spacecraft are powered with just the sun's light alone. People on Earth wonder when will they see the first human space sailors and even space pirates. The first crewed mission lands on the Martian moon, Phobos. Humanity's in-space manufacturing abilities begins to mature. Massive beams are printed and knitted together by a red-wire Archinaut spacecraft, allowing for structures to be built like spiders, larger than any rockets can carry into space. People on Earth are shown concept art of massive space structures, showing multi-kilometer trusses, skeletons of spacecraft, New Age telescopes, and space station worlds. Humanity starts to daydream of limitless-sized space structures.
An announcement is made on Earth, stating that humanity has officially become a multiplanetary species.
Orbital mechanics is being taught in middle schools, along with space law. A space creole, a language, is already developing. Words combined from languages on Earth are being used to describe the new and alien sensations of living in space. AI engineers have trained the first AI capable of managing solo an entire spacecraft. It is able to carry out missions autonomously, setting its own goals, objectives, and is able to create new missions of its own. There is a heightened need for asteroid defenses, as humans now have 3 settlements on Earth, Lunar, and Mars. Tests are conducted on implanting thrusters onto asteroids as a way of redirecting them. Another test mission has the name Gravity Tractor 1. A large spacecraft is deployed, flying alongside a small asteroid. Without touching, the small gravitational pull of the spacecraft is enough to make a micro-adjustment to the path of the asteroid. The construction of the largest rotating spaceport begins, creating what some people are calling a garden in space. The wheel-like structure with a rotating outer ring creating artificial gravity is able to house 450 people, including scientists and tourists. (2051), the second Great Crossing. 200 starships launch from Earth's orbit, and thousands of people land on the Red Planet. Jupiter's moon, Ganymede, becomes a target for crewed exploration. On Earth, humans are able to do weekly commutes, taking shuttles to space stations where they work and returning home for the weekends. There are even public shuttles that have daily timetables. The first lunar space race takes place, named the Slingshot. Spacecraft set off in orbit around Earth, racing around the moon and back again. Others are watching from their own spacecraft. Space adventurers begin flights in solo one-person spacecrafts. All critical flight and support systems are managed by an onboard AI. The AI communicates and is authorized to fly by Earth's AI space flight control. Some of these space adventurers work on building their own DIY versions using an open-source AI piloting system. They are called Do-It-Yourself Autonomous Spacecrafts, or DAs. Mad scientist studies are being done on whether it could be possible to manufacture a spacecraft made primarily out of biological components, chitin, cellulose, or bone. These spacecraft get the name bioships. Meanwhile, a network of quantum computers brings into existence artificial general intelligence. Soon, this super AI will be sent in spacecrafts and beamed across interstellar space as data. When this happens, there will be planetary bodies that are inhabited by only artificial intelligence. The first person is put into sleep mode. Their body is brought down to a lower temperature, between 32 and 34 degrees Celsius or 89 to 93 degrees Fahrenheit. In a state of deep slumber, the heart rate is reduced and metabolism slows down to a near halt. Oxygen needs decrease, and even aging is slowed down. Calculations show that even for a small crew of 4 to 6, the habitat mass, aka the supplies, equipment, and living spaces needed, is reduced by 70 to 90%. This hibernation of sorts is made possible by advances in torpor inducement, a technique for replicating mammalian hibernation. When entering the pod, an astronaut won't feel any coldness. The temperature slowly changes, and they are injected with compounds to induce the state of torpor. The goal is to have deep space spacecraft with chambers filled with these torpor-inducing transfer containers, called hypersleep pods. A crewed mission lands on an asteroid. They test optical mining. Large reflectors concentrate sunlight, excavating and extracting resources, while enclosed in a containment bag. Ion thrusters are fixed onto the asteroid. It is now under human control and put into orbit around Mars for larger-scale mining. A test spacecraft uses a stack of crystals, piezoelectric crystals, as fuel. These crystals are normally used on Earth for sonar. An electric field causes them to have tiny changes to their resting masses, making them a little lighter and a little heavier, generating momentum. This type of propulsion does not require any propellant, which allows for interstellar travel. A few milligrams of antimatter are used to propel a spacecraft all the way to Mars. About 10 billion times the energy is produced compared to traditional chemical combustion rockets. The antimatter particles are created on Earth from ultra-high-speed collisions made at huge particle accelerators, such as the newly built Ultra-Large Hadron Collider. It is also found in bananas. The interstellar ramjet is an advancement of the nuclear fusion engine. Instead of feeding from the spaceship's onboard fuel, it harvests and burns hydrogen floating in space. An electrically generated magnetic field at the front of the spacecraft acts as an invisible scoop, a funnel that collects the hydrogen floating in space. Accelerated into the ship's engine, it reaches temperatures high enough for fusion. Travel routes are mapped based on the presence of rich interstellar hydrogen. Interstellar space can be rich in gas, especially around star formation regions and young stars. In images of the Horse Nebula, a cloud of ionized hydrogen glows red in the background, while supercooled hydrogen is seen in the dark molecular cloud in the front, part of the famous Horse's Head. A ramjet can reach the center of the Milky Way in 21 years of ship time, which is 45 years on Earth, because of the relativistic effects. Humans have mastered the taking over of asteroids, landing their spacecraft and implanting thrusters to maneuver them, laying the foundation for the next phase of asteroid manipulation. Plans for the intra-asteroid space station show a habitat burrowed 100 meters deep inside of a mined, hollowed-out, rotating asteroid. After an asteroid has been mined, the shell can then be used as a structure, acting as an ecological shell protecting its inhabitants from radiation. Gravity is provided from either the asteroid's natural rotation or implanted thrusters provide and maintain the spin while also directing the path of the asteroid. Dyson trees are planted. These are genetically modified plants engineered to grow inside of a hollowed-out asteroid. Designed for oxygen production, they help create a small and contained human habitat and ecology inside of an asteroid. A space station is placed around Jupiter's moon, Ganymede. It is the largest moon in the solar system, with its own magnetic field and subterranean ocean. It becomes humanity's deepest deep space crewed outpost. A Neuralink brain chip merges with a spacecraft, creating a neuronal ship. Testing of the first Alcubierre warp engine goes live, reducing travel times from years to hours. A warp drive expands the space behind the spacecraft and squeezes the space in front, creating a bubble. The spacecraft is surfing over the fabric of space-time. It is much like a human standing in a swimming pool, pushing the water behind so that the water in front and even the leaves floating on the water moves towards them. There are no relativistic effects with a warp engine. Missions are achieved in just a few years, coming back to Earth where both the crew on the ship and people on Earth age at the same rate. Replicants are being sent to other planets. These self-replicating microbots are programmed for terraforming, slowly converting a planet's atmosphere. They use the resources on the planet to self-replicate and multiply, built with high-density DNA storage to remember their terraforming instructions. 1 gram of DNA can store 215 petabytes of information. Similar to cells and bacteria, the number of robots increases exponentially when left unmonitored. Spacecrafts now have biobag chambers on board, artificial wombs filled with amniotic fluid, fully supporting the entire development of a human fetus. On Earth, animals such as lambs are born the same way. Outside of the solar system, a spacecraft approaches a spherical passage. It is a wormhole, also known as an Einstein-Rosen bridge, created by an incredibly dense supermassive object opening a hole in space. It would be like putting a bowling ball on a trampoline, but the bowling ball is so dense and heavy that it keeps pulling the middle of the trampoline down. When it touches the ground, it is like touching another part of the universe. The astronauts on board the spacecraft are studying how to make the wormhole stable, as they are known for collapsing almost immediately after their formation. If the astronauts can find a way to fill the wormhole with exotic matter, the passage could remain open long enough for the spacecraft to pass through. The advanced multiplanetary civilization of humanity begins discussing whether there is a need for placing a megastructure close to the Sun. It would be called a Shkadov thruster, a stellar engine. It is a megastructure similar to a huge parabolic mirror placed close to the Sun's pole, used to propel an entire star system. The mirror reflects most of the Sun's light back at it, creating forward thrust. This means that the Sun and all of the planets, moons, asteroids, and human-made space structures in the solar system can be guided along a path chosen by humans, ensuring the safety of the solar system and turning humanity into a stellar civilization.